Geometry, Chapter 5, Section 1, Mid-segments of triangles. In this lesson, we're going to use properties of mid-segments to solve some problems. Alright, we're not going to do that example, so here we go. The mid-segment of a triangle is a segment connecting the midpoints of two sides. Okay, so here's our theorem. If a segment joins the midpoints of two sides of a triangle, then that segment is parallel to the third side and is half as long. Alright, so if D is the midpoint of CA and E is the midpoint of CB, then DE is parallel to AB and DE is half of AB. Okay? Here's why it works. You can verify that the triangle midsegment theorem works for a particular triangle. All you have to do is prove the following steps. So here we go. Use the midpoint formula for M to find point D. The sum of the x's divided by 2 of point A and C, and the sum of the y's divided by 2. So the midpoint of CA is point D, which gives us the values of 2, 3. The midpoint of CB, again, is the sum of the x's of b's divided by 2, sum of the x's, or sum of the y's of CB divided by 2. So point E is 3, 0. So to show that mid-segment is parallel to side AB, all we have to do is find the slope of each. The slope is y2 minus y1 over x2 minus x1. So the slope of DE is negative 3 over 1, which is negative 3. The slope of AB is negative 6 over 2, which is negative 3 as well. Third and final step is use the distance formula. And I'm not going to go through it all, but here's the formula. The distance is the difference of x's squared, or the square root of the difference of x's squared plus the difference of y squared. Alright, so we see DE is 1/2 of AB. So we proved it mathematically. So identifying parallel segments. What are the three pairs of parallel segments? Alright, RS is parallel to DTF because we know RS is a mid-segment. DE is parallel to TS because TS is a mid-segment. And RT is parallel to EF because of mid-segments. So we're able, by mid-segments, be able to find three sets of parallel segments. Alright. In triangle XYZ, A is the midpoint of XY. B is the midpoint of YZ. So let's draw this triangle up. So I have a triangle. X, Y, Z. A is the midpoint of XY. B is the midpoint of YZ. And C is the midpoint of XZ. What are the three pairs of parallel segments? Okay. Let's go ahead and draw our three mid-segments. So segment AB would be parallel to XZ. BC would be parallel to XY. And AC would be parallel to YZ. Alright, in the figure at the right, what is the measure of angle VUO? Well, let's look. I know NM is parallel to UV. I know that because of the mid-segment theorem. So, by corresponding angle postulate, angle VUO must be congruent to measure MNO. So the measure of angle VUO should be 65 degrees. Okay. Problem 2. In triangle QRS, TU and B are the midpoints. Okay, I'm looking at this example right here. Use the relationship length of mid-segment to write an equation about the length of the mid-segment. Okay, so it says find TU. Find all those. All right. Well, let's look. TU, I'm going to highlight that in green, is 1/2 of this one. So what's 1/2 of 40? So TU is 40 over 2, which is 20. Okay, the next question says, so I'm going to write right here 20. What is UB? Well, UB is right here. It's a mid segment. So it is 1/2 of 50. So UB would be 50 over 2, which would be 25. What is QR? The last one. Let's look. What is QR? Well, we know that mid segment right there is 30, and QR has got to be twice that. So QR equals 2 times 30, which would be 60. So QR is 60. In the figure at the right, AD is 6 and DE is 7.5. What are the lengths of DC, AC, the whole thing, EF, that one, and AB, and that one? Okay, so let's look. What can we prove and how can we prove it? Well, we know AD is congruent to DC, so 6 must be equal to DC, so we prove DC. AC is nothing more than AD plus DC, so that's 6 plus 6, so AC must equal 12. Again, pretty easy to prove that one. EF, well, we know EF is 1/2 of AC, so EF must be 1/2 times 12, or we could say EF equals 6. So AB, well, we know AB is equal 2 times DE, so AB is equal 2 times 7.5, so AB must be equal to 15. Make sense? Mid segments. Okay, using mid segments of a triangle. Okay, this is a great example. A geologist wants to determine the distance AB across a sinkhole. Choosing a point E, and I'll use my yellow highlighter. Well, maybe I'll use a different color. Maybe I'll use red. Circle point E outside the sinkhole. She finds the distance of AE and the distance of BE. She then measures CD. What is the distance across the sinkhole? Well, using the mid-segment theorem, we know DC is a mid-segment. It has a length of 46. So BA must be equal 2 times CD. So BA, or the width of the sinkhole, is going to be 2 times 46. BA is going to be equal to 92 feet. Pretty neat. It's a pretty neat way to be able to find distance when you can't get direct measurement yourself. All right. CD is a bridge being built over the lake as shown. What is the length of the bridge? Well, we know CD is a mid-segment, so we know the long length. Let's highlight that. This long length is 2,640. So we know CD must be equal to 1/2 of whatever that distance was, 2,640. So the bridge CD must be equal to 1,320 feet. Okay. So we're just going to read this to you guys and talk through what are properties of mid-segments can help you solve problems. Well, we know mid-segments are parallel to the third side, so you can solve problems using the properties of parallel lines. The mid-segment's half the length of the third segment, so you can also use that to find mid-segment sides or lengths. All right, last example. We're going to do these three. What segment is parallel to JK? Well, NO is pretty simple. If LK, that's this long side, was 46, what's NM? Well, NM is a mid-segment, so it's going to be half of that. So what's 46 divided by 2? 23. Okay. JK is 5x plus 20, and NO is 20. What is the value of x? So we can say 2 times NO equals JK. So 2 times 20 equals 5x plus 20. So that's going to be 40 equals 5x plus 20. Subtract 20 to each side, so 20 equals 5x. Divide each side by 5, so x must equal 4. Okay. That pretty much sums up how we deal with mid-segments.